Thanks everyone for joining. I see we have quite a few guests from all around the world, so thank you very much for joining. Today, in this presentation, we're going to be talking about SlickLight-C, electrically enabled slick line for real-time downhole communication and power. My name is Alex Sacevic. I'm the sales manager for Wires and Bytes, and I'll be co-presenting with Peter Basic, VP of Technology. So this presentation, we're going to cover the applications of SlickLight-C in oil and gas wells. And we're going to talk a little bit about the company, and then we'll dive into SlickLight-C, how it's designed, what it looks like on the inside. We'll talk a little bit about the success that we've already had as a company. Peter is going to talk about what's coming, and we'll finish off with conclusions and questions at the end. So let's get started. So what are the applications of SlickLight-C? So as many of you probably know, SlickLight-C is a digitally enabled slick line. And so the applications are, the first one is slick line conveyance. So essentially what SlickLight-C enables us to do is to communicate real time with all wireline tools. So traditionally, slick lines have been using memory tools, going down into the well to evaluate it. The downside there, of course, is you have to wait for that data, wait until you're out of hole. Well, SlickLight-C enables you to make real-time decisions and see real-time data. So no more waiting. So you can use any and all wireline traditional tools, CCL, gamma, CBL, pressure, temperature, many more digital and analog tools, all while using the same slick line pressure control equipment. Makes it very easy for our customers. The other application, of course, is coil tubing. So SlickLight-C can be injected into coil tubing. And what this allows our customers to do is to make real-time decisions for drilling out, for coil drilling, and that kind of thing. So when you're providing digital signals down to the bit, you can get downhole weight on bit, downhole torque, downhole vibrations. Some of our customers are even running triple combos for advanced coil tubing drilling situations. So SlickLight-C enables you to do that. So let's move on, talk about Wires and Bytes as a company. So Wires and Bytes is a subsidiary of InCab America, and InCab is a manufacturer of telecommunications, power and utilities cables globally. And Wires and Bytes is the oil and gas subsidiary of that company. Started in 2019, we've delivered many services around the world so far. Manufacturing happens all over the world with our partners at InCab. And one thing I want to stress is that all of the design, the building, the assembly of the cables is done in-house. So that's one strong suit to save time and money. Each cable is also tested in-house for mechanical strength, electrical capabilities, optical, if we're talking about DFOS, temperature pressure testing, and also we can customize our testing based on what customers are looking for. And of course, with every cable, we send out an authenticity report for the test. Let's go into SlickLight-C and its design characteristics and specifics. So SlickLight-C is essentially a capillary tube-based slick line. So there's a capillary tube on the outside with a copper conductor on the inside. We currently offer two different versions. We have a basic version on the left where the strength is provided by the outer tubing only. Smaller ODs are possible. Copper conductor allows you to have real-time data. And that's the basic version. On the right, you see the advanced version that incorporates strength members and also improves the electrical return path, increasing the strength, increasing bending performance. And so for the rest of the slides here, we're going to be talking about the advanced version on the right. So here's a picture of what it actually looks like. As you can tell, there's a smooth outer alloy encapsulation, encapsulating strength members, encapsulating insulation, and encapsulating the copper conductor. So again, it's capillary tube based for rapid telemetry and electrical power to tools downhole. The armoring provides a better return path and also increased strength. And one thing I'd like to stress is every single cable is designed and built specifically to our customers' needs. So we don't have off-the-shelf cables. We work directly with customers to understand what it is that they're trying to do, what services they're trying to run, and we build a cable specifically for that purpose. So moving on, the three major benefits to this cable. Again, real-time telemetry to tools. This cable can power tools, including tractors, and we can manufacture this cable up to 30,000 feet without sacrificing telemetry and power. And the way this is done is that the cable, once again, is fully customizable. So we can customize the conductor AWG rating, the strength member size, the outer tube material, resistance and capacitance per length, the OD as well. And so every aspect of this cable is fully customizable down to basically everything that you see in this labeled diagram here. But in essence, SlickLight-C combines wireline capability with SlickLine simplicity. So we've been a company since 2019. Since then, we've worked with quite a few partners around the world. In America, we're working with TTS, Through Tubing Solutions, in the Marcellus. We're also working with ACOS out of Texas, and they've used our product in coil tubing. GoWell in Qatar is also using currently our product in coil tubing as well. But our biggest customer is Expro, where we have lines deployed in Argentina, North Sea, Middle East, OilServe in Iraq, NIMR in Saudi, WSG in the Netherlands, and some research work for the University of Auckland in New Zealand. So obviously we're trying to grow, we're trying to innovate, trying to expand specifically in the US market. Now I'm going to pass it along to Peter Basic, our VP of Technology, who's going to talk a little bit about what's coming.
Yes, thank you, Alex. Is there any questions so far? No. Okay, so basically we are actually continuously doing our R&D, actually, you know, listening to the market and also the customers about the application, their needs. So basically, this is how we conduct research and development, and I just want to show these few designs which we are working on right now. So the right one, the left one, as you can see, in the armor we are combining steel with aluminum wires. For example, it will dramatically decrease the resistance of the armor and encapsulation, for example. So even less electrical resistance in that design which we are testing. So basically we are, it's always, of course, a trade-off between these parameters, the size, the type of material, and the design, so mechanical and electrical features, of course. And the right design, we actually have two copper wires, high temperature, and one FIMT. In these, I would call a star configuration. Here we have more benefits, actually. As you can see, more gap is included, so more void between these three stranded elements, which will further decrease capacitance. And then also we have some advantages of the inductance because everything is twisted and we can control the twisting, mimicking, for example, high-speed internet cables. So we are testing also these designs, and according to the calculation, there's also the experience. First, we will be having a much lower capacitance with that designs. Still, everything is, slick line size up to 4.8 millimeters, and that's a little bit of our R&D activities which are ongoing. Alex?
Thanks, Peter. So as we're wrapping up this presentation, I wanted to kind of shed some light on the next webinar that's coming in 2 weeks, where we're going to be discussing SlickLight-H and SlickLight-S, which are hybrid fiber optic and copper cables and fiber optic only. And what those cables are the best use for is frac monitoring, leak detection, P&A work, using DTS, DAS, fiber coil applications, where the actual fiber itself is the sensor and you can see the entire well all in one shot. So we're going to be talking a lot more in depth about this in 2 weeks. So if you're interested, feel free to let us know. We'll be sending out a follow-up email. So join us there. So to conclude, as I've talked about, SlickLight-C is a digitally enabled slickline product that has a copper on the inside, allows for real-time communication and power to tools, essentially using any and all wireline tools. Each cable is designed in-house, can be made up to 30,000 feet, and we work together with our customers in order to build the best package possible. And lastly, Wires and Bytes is always innovating, always creating new products and ideas, and we're working with our customers as well to make strides in this industry. So I want to thank everyone very much for coming, for joining. I'm going to open up the floor now to any questions that you guys might have. So open up the floor. Thank you very much. Any questions?
Yeah, when you said that you could do 30,000 feet continuous, will that apply to the other cables as well without conductors?
Do you mean fiber optics?
Yes, even the options with the aluminum in the innards.
Yes, that is our objective. Yes, which is not a big something. It's not an issue at all because everything is ready to produce actually easily. I mean, 15-kilometer continuous length. So that will be, yes, an objective.
If something does break during construction, how is it handled?
During the construction?
Yes.
How is it handled, or?
Yeah, so if I ordered 30,000 feet and you're making my cable and it breaks at 20,000, what do you splice it back together, or do you do a new cable?
We do a new cable, of course.
Okay, thank you.
We are guaranteeing, when you say 30,000 feet, then you get 30,000 feet.
Hello, it's Ron here, calling from Canada, or listening from Canada. In 2006, we built a line a lot like this. Ours was best efforts on length, so we ended up with a bunch of different lengths, and it's getting really tired. So this is very interesting. We're looking probably to replace something, and I don't see you have anyone in Canada, so that's pretty interesting. Very interested in braking strengths, how your rope socket connections look, that kind of thing. Because we literally have this. We're down to like our last line under 5,000 meters, and it's a challenge. We're scared to go out and work it too much because we don't have much backup. But so we've been in this game for a long time, and I like what I'm seeing here.
Yeah, we know that the Canadians are much more involved with the cables that we're using. But yeah, Ron, let's connect offline, and we have your emails, and we can work together, see what you guys are working with, and get you those numbers.
Perfect. Thanks.
Yeah.
All right. Can you hear me? This is Homero.
Yep.
I have a,
So the steel and aluminum wires, the additional ones that you're adding, including the actual FIM, do you control the chemistry of those metals, or do you buy those wires already from the market and you just use them?
well, I think we buy them actually in the market, but since we are involved in also other industries, we know all the sources, and we can say we are in the complete control of the aluminum and steel.
Is that true for the conductors? The 7 elements that you show in there, presumably copper.
Yes, yes.
Do you buy them all threaded, or do you actually control the chemistry of the copper and the shaping of that conductor?
So the wires are actually, we buy the wires and we make the conductor out of it. We put the insulation. This is all internal process, but we buy the metal we buy.
Okay. I ask these questions because when dealing with wireline cables, in particularly multi-conductor ones, when it came to address the compromises between strength, ductility, and size, it was very apparent that there was one company that had full control over the entire generation of the material and packaging, and became significantly preferable to work with those and leave behind for the cheaper, simpler markets, those who just package elements into wireline cables, right? The prices were different, but the performances were different. And this is what allows us to operate on deep water, for example, extremely long, tortuous wells and so on. So that compromise was achieved on the design by changing the chemistry of the metal, which is what I asked. Presumably your suppliers, you can also specify that they can make wires the way you want them, right? But
Of course.
doing it yourselves gives you another dimension. That's what I asked. But good.
Yes.
All right. Thanks for the answer.
Yes. Well, we use a lot of metal, not only for oil and gas industry, for the overhead power lines, OPGW. You have to have control you have to have a good control over your metal sources, and this is just extending the knowledge, or using the same knowledge into the oil and gas.
All right. Thank you.
Thanks, Homero.
You're welcome.
Anyone else have any questions?
I do have one more if you guys have time.
Yeah.
The way you test your wires or your cables, and I saw a couple of pictures that suggest that you do it over sheaves, or at least drums, when they are wraparound drums. It's like the image on the middle and the image on the right. It almost suggests that you actually have a table that you can be running those drums along the length with tension. Is that what you have? Do you have a full fatigue test with repetitive cycles, and where you can monitor the integrity of the conductors as well as the fibers or the tubes, as you can count the number of cycles, that kind of thing? You know what I'm talking about?
Yes, of course. So this is just a part of the lab. Actually, the right is for the temperature chamber. The picture in the middle is the tension bench, and then you have these sheaves which are fixed and which are rotatable. And then for the fatigue test, you can put that picture, Alex, for the repeatable bending.
Yeah, sure.
The new machine, actually, we have a picture of that as well. Yes, so this is the repeatable bending test batch built for the slick lines. So you can change the sheaves, and then of course the load, your slick lines, in our case, we can exceed actually 500 kilos, of going to more than 500 kilos. And then you just, like you do with the telecom cables, you just walk the shaft left and right and count number of cycles and applied tension, and then you make some statistics. You get experience. You get information on your design, and so this is what we do on the mechanical side. We have for the electrical side everything what needs to be done as well, like the resistance, the capacitance, which are two major stuff, and then having even more for the fiber optic side. So there's everything, I think, which somebody needs to characterize the slick lines properly.
Okay, yeah, this is what I was looking for. All right, thank you.
Thank you, Homer.
Anyone else have any questions? We will be sending out this presentation as well afterwards as a follow-up. So if you think of anything later on, you can absolutely reply, and we'll get to that question.
Just one more information from my side. Maybe we need to also tell today that our facility for the tubing is growing, actually. So we have two laser welding mills, and then we just added the third one, which is actually for the thicker designs and even larger outer diameters. So basically, the customer can, of course, all based on the technical requirements, wishes, and everything, we can select which design we go with a, let's say, thin wall or single layer, which design we go the multiple layers in the encapsulation, and which design we go with a thick wall, the tubing. So we have a lot of options in that range, and actually this will be communicated in the time to come. It's a brand new line, actually, and we are just working with it since I think April, and then we'll be just adding these possibilities to our products.
So Peter, you're saying a single thick wall
Correct.
is coming? Okay.
Yes. So our present sizes are 4.0, 4.8, and then we go 9 millimeter size, and wall thickness will go up to 1.24 millimeters. So we have a quite unique tubing facility now. Just as information.
Well, great. If we don't have any additional questions, I guess we can wrap it up. As always, if you guys think of anything, have any follow-up questions, a follow-up email will be going out with the link to this recording. So definitely don't be shy. But I do want to say thank you from everyone at Wires and Bytes. Thank you all for joining. It was a pleasure being able to present to you guys, and hope you have a great rest of your day. Thank you very much.
Thank you. Thank you very much.
Right.
Take care.